Hello everyone, welcome to the presentation session for PLAS 5970, in which I'm going to discuss regarding the compounding and characterization of recycled multilayer plastic films. I will begin my presentation without any further delay. So starting with the introduction, a significant amount of the polymers that are produced all over the world are utilized in the production of multi-layer food packaging films, among other applications for plastics. When they have reached the end of their useful lives, multi-layer films are notoriously difficult to throw away. It is difficult due to the fact that it requires a combination of a few different kinds of materials in order to create the framework of the package. They also contain a number of additives, many of which are pretty much unknown and can be difficult to identify as well. Besides, they might also use paper, metals, and other materials in their construction in addition to polymeric components. Also, the condition of processing for each polymer that is employed in multilayer films are completely distinct from one another. So as a result, conventional recycling processes for plastics cannot be utilized for the purpose of recycling multilayer packaging materials. So in this slide, we will talk about the experimental design. So the primary objective of this work is to combine used multilayer films for food packaging with virgin LDPE in a range of proportion and then describe the resulting mixture so that they can be used commercially. The following is an outline of the experimental design that was drawn up in this case. So the recycle multilayer films via mechanical processes such as separation, washing, drying, pressing, grinding, and compounding are the major works that was done in this work. Besides, several different compositions of multilayer film flakes were produced by using virgin LDPE as the precursor material. And after the multilayer film flakes had been dried, an extruder with tuning screw was utilized in order to extrude the compounds, and the ASTM D638-6070 standard required injection molded specimens for tensile testing, and those specimens were made in compliance with standard. In this slide, we will talk about the materials and methods used in this study. In terms of material composition, multilayer film waste is composed of 56.7% polyethylene, 13.5% polypropylene, 9.5% polyamide, 7.8% PET, 4.5% PE/PP copolymer, and 4.1% print with 2.0% EVA along with EVOH. So compounding was basically done with virgin LDP grade material intended for the film extrusion. In the steps that came before the compounding processes, multilayer films were first crushed into flakes and then compressed into thicker sheets using a hot press. When the virgin LDP was combined with the substantial percentage of multilayer films, higher screw speeds were utilized in the compounding process. The tensile strength, strain and break, and Young's modulus were the three matrices that were used to characterize the material's mechanical properties. The Fourier transformation infrared uh, was basically used for the purpose of determining newly formed chemical bonds. The determination of materials' physical properties were carried out using DSC. In addition to that, rheological measurements of the material based on its viscosity were carried out as a part of this investigation. Here you can see the pellets that were manufactured are shown here with a range of different concentrations of multilayer films. In order to prevent the thermal degradation, multilayer films that are extruded and have a variety of various compositions used in twin screw extruders with a short residence time. The pellets that included between 80 to 100 weight% of multilayer films had a cellular structure, and the cross sections of the extruded strands that contain between 60 to 100 weight% of the multilayer films were not spherical at all. So now I will proceed to discuss the results that were acquired from the experiment in a logical fashion. As a part of the result explanation, this slide demonstrates the mechanical characteristics of multilayer film compounds. It is pretty much evident that from the table, the compound consisting exclusively of virgin LDP achieved the highest tensile strength of 12.7 megapascal. This was accomplished by the compound. The tensile strength of compounds increases proportionally with the volume of multilayer films and that are present in the compound. The tensile strength of a film that was 100% multilayer was 30% lower than the tensile strength of a film that was of 100% virgin LDP. The material's modulus is greatly increased due to the relatively modest number of distinct polymers that are used in the multilayer films, which basically served as reinforcement. So here you can see the Fourier transformation infrared technique is basically used to illustrate newly formed chemical bonds. The peak that indicates LDP becomes less prominent whenever there is a lower concentration of LDP in its purest form. An increase in the concentration of the multilayer film results in the creation of additional broad peaks. Beside the polyamide is represented by the bending of NH and the stretching of the CN bond at a frequency of 1538 per centimeter. This is representing polyamide, and large peaks that is seen at 1080 to 1180 and 1242 to 1200 region respectively suggest that the molecule has recently added with PET ethylene vinyl alcohol and ethylene vinyl acetate. So here you can see the differential scanning calorimetry results of the compound, which is presented on this slide. The DSC curves that were generated from the second heating after the effect of material's previous thermal history had been eliminated are shown in this instance. Where there is an increase in number of multilayer films, the amount of virgin LDP that can withstand 115 degrees Celsius, a shoulder and a secondary peak at 125 degrees Celsius have been emerged, most likely LLDP, which is linear low density polyethylene, in a manner analogous to that of polyamide. The amount of multilayer layers contributed to an increase in the melting temperature of polypropylene. So this slide provides an illustration of the rheological measurement of the compound based on its viscosity. Because polyamide and PET particles don't completely melt at 220 degrees Celsius, they continue to exist as solid particles within the complex. This significantly increases the viscosity of the liquid. During the processing stage, polyethylene can suffer from thermomechanical degradation, which can lead to cross-linking and an increase in the viscosity. Increase in shear rate have a greater impact on the viscosity of the compounds than those of virgin LDP. So now we shall undertake an analysis of the current status of this task from this slide. As a part of analysis of the study's strength, this presentation provides an overview of the analysis of the study's strengthening point. According to the findings of the study, multilayer films have the potential to be mechanically recycled into a compound with immiscible polymers and suitable mechanical properties if the appropriate recycling procedure is utilized. Besides the fact that a compound made entirely of recycled multilayer films demonstrated a high strain at break, which is around 135%, which made it very useful for a variety of applications, was particularly remarkable as well. This research would encourage industries to focus on recyclable things, which would result in a decreased reliance on plastics obtained from fossil fuels by those businesses. Beside, this would be a first of kind discovery if it were confirmed that addition of compatibilizer during compounding didn't have a substantial effect on the mechanical properties of the immiscible polymer mixture that was formed from recycled multilayer plastic films. So I also want to focus on the study's weakness as a part of the analysis. A critical examination of the limitations of the research is presented on this slide. The primary criteria for comparing virgin LDP and multilayer films in terms of their compositional selection has not been sufficiently proved as of yet. By observing the morphology of the complex compound, one can qualitatively verify the level of immiscibility that exists between two substances, basically the polymers. In order to accomplish this goal, scanning electron microscopy may be utilized. This technique has the potential to deliver qualitative data regarding the surface morphology as well as the quantitative data regarding the physical properties of the substances. It would be helpful to get data on the impact strength if one wanted to gain a comprehensive understanding of the mechanical features of the compound materials and narrow down the applications for using those materials. The particle size distribution of the flakes as well as their influence on the mechanical qualities of the compounded materials were not in the least bit investigated, and there are no recorded suggestions for any particular approach to improve the material's mechanical characteristics, either or with or without the use of compatibilizer. This slide basically provides an overview of the potential future work that can be done to investigate a variety of qualities in greater depth. Examining the morphology of the compound through the use of scanning electron microscopy, which can identify the presence of voids in a compounded structure that have a significant impact on the compound's physical properties, is one way to qualitatively determine the level of immiscibility that exists between two polymers or substances. The selection of additional compatibilizer in the compound could lead to increased performance in new materials, making this an interesting field for future research as a part of the project that has been proposed for investigation. This slide illustrates the value that may be derived from recycling multi-layer grade plastic films by mechanical means. In a wide variety of contexts, recycled multilayer films have the potential to serve as at least a partial replacement of virgin LDP. If recycled materials were used, there would be less of need for the polymers that were created from fossil fuels. It is possible to turn multilayer films that have been recycled mechanically into a composite material that consists of immiscible polymers and has mechanical properties that are pretty much acceptable to all. These are some of the references that were considered useful during the course of this study and also were utilized during the process of putting together in this presentation. With this, it concludes my presentation for today. I want to express my gratitude to those who have taken the time to listen, and I also invite you to get in touch if you have any queries. Thank you again. Thank you.